Section 921 in the CPM book starts with question 49. And it asks us to look at a roller coaster that our friend Alfredo is riding. And he noticed that a portion of it is shaped like a parabola. It says near the base of the parabola, the track goes underground into a tunnel. A car on the track speeds toward the tunnel from 300 feet above ground and reemerges above ground 100 feet to the right horizontally. The first question asks us to write an equation for the car on the track, where x is the horizontal distance and y is the vertical distance, both in feet, and to state an appropriate domain for the situation. Well, the information that we're given is kind of scant. We definitely could use some very key points here to figure out the equation. For instance, we would need to know that the starting point up here, or rather the y-intercept, is 0, 300. That's where we begin the portion of the parabola. Our first point would be here. I'm sorry, our first 0, where we're heading the underground section, would be at 50, 0, which is 50 feet from um, the drop point. We travel 100 feet underground and we reach the ground level again at, let's see, 50 plus 100 is 150. And we could definitely use that information with y equals some scalar we don't know because we don't know how wide this opens up. But some scalar times x minus 50, x minus 150 for our roots of 50 and 150. Multiply that out, use this 0, 300 to find your scalar to solve for a, substitute that back in, complete the square. That is definitely something you can do. If you are one of our honor students, I challenge you to pause this video right now and give it a shot. For those of you who are choosing to not be challenged, what I would do here is give you a little bit of a hint that oh, that was a terrible. Let me try one more time. A little bit of a hint that the height or the depth that the car goes is 100 feet deep. So once it gets into the underground section, at its lowest point, that is 100 feet as well. So this point here, our vertex, is going to be at 100, negative 100. And we'll go ahead and use that to make our equation just in the interest of time. Um, our equation is going to be y equals, again, we still don't know what the scalar is, so let's go ahead and use a for the scalar. And then we can say that our x minus h would be the 100 from our distance going here. Square that, and that'll be minus 100 for the distance going down. In the interest of small numbers, let's go ahead and use this point 50, 0 to solve for the a. So our y would be 0 equals the number we're trying to find out, 50 minus 100 squared minus 100. And in doing that, add 100 to both sides. In doing that, we just kind of make it a little bit easier on ourselves. Let's see, 100 equals a times a quantity of 2500. Divide both sides by 2500. We'll get that a equals 1 over 25. So our equation in the graphing form, the vertex form, will be that y equals, a is 1 over 25, and the rest of the equation we know, x minus 100, quantity squared, minus 100. And since we are looking from this point to its mirrored cousin on the other side here, fairly appropriate domain would be somewhere in the neighborhood of 0 from here. We add 50, we have to add another 50 here. So that'll be 0 to 200 feet.